All right, let's continue on to section 6.4, polynomial equations continued. A couple of abbreviations there. This has a lot more complication to it than the previous section. Consider this polynomial. It's a fourth degree polynomial. Suppose you'd like to know, is -2 a root of that polynomial? Well, you could plug -2 in place of x and calculate it out that way. Here's another way. Asking this question, is -2 a root of this polynomial? That's the same as asking the question, is x plus 2 a factor, right? We've used that principle a lot of times now. One way I can answer that question is to perform long division of polynomials. You might say, well, we divide numbers. How do you divide polynomials? But keep in mind, we did a couple of weeks ago divide functions, right? We divided a function f by another function g. This is essentially the same concept. This can be thought of as a function. If you just say f of x equals this, and if you say g of x equals this, oh, I'm dividing one function into another function. But how do you do that? Well, set it up like a long division problem like you did way back in grade school, where you divide one number into a bigger number. In this case, I divide x plus 2 into this. What do I need here to get that x to the fourth to cancel out? Well, I need an x cubed, because x cubed times x gives me x to the fourth, and x cubed times 2 gives me 2x cubed. I can't lose track of that, even though that's not what I want. I wanted this set up here because this subtracted from this leaves 0. So I've gotten rid of the x to the fourth term in my resulting quotient here. However, when I subtract 2x cubed from 6x cubed, I don't get 0. I get 4 times x cubed. All right, and of course I have the rest of this polynomial here. Right, I bring down these terms. Let me fix my x. All right, so the next thing I'd like to do is get rid of that 4x cubed. What would I have to multiply by to make 4x cubed appear here? Well, positive 4x squared, right? The positive 4x squared hits the x and gives me 4x cubed. So it will cancel out. The 4x squared hits 2, I'm going to get 8x squared. I subtract. These cancel out, I get 0. Over here, I get minus 3x squared. Now, what do I need to multiply by to make a minus 3x squared appear here? I'll need a minus 3x. Minus 3x hits the x, gives me minus 3x squared. Good. Minus 3x multiplies with that 2, and I get minus 6x. And, of course, I could bring down this minus 4x here. I got to keep track of that. And the plus 2, if you want to write all the stuff. These subtract, give me 0. These subtract, and I get a positive 2x plus 2. So you see I'm getting close. I'm down to a remainder now that is just a single power of x. What do I need to do to get rid of that 2x? Well, I'll multiply by 2. 2 times x gives me 2x, good. 2 times 2 gives me 4. I subtract, the x terms go away. 4 subtracted from 2 gives me a negative 2. And that's as far as I'm going to get. There's nothing I can multiply here that's going to get rid of that minus 2. Because if I multiply by another number, it's just going to put the x's back in there and I'm never going to get anywhere. So this is my remainder, negative 2. But if x plus 2 was truly a factor of this polynomial, there would be no remainder. It would factor completely. So, the conclusion, minus 2 is not a root of this polynomial because x plus 2 is not a factor. Alright, so we figured something out there, but it was a lot of work. Now the beautiful thing about math, the thing that makes it better than all your other subjects, is you're always looking for the easiest way to do something. In English, your essay has to be 500 words. Even if you could say it all in 300 words, the teacher makes you write 500 words. In history, you gotta read all this stuff, even if you can get the ideas from just a few statements, you gotta read all these original writings of the authors. And yeah, it's a lot of work. But here in math, we're always making it as little work as possible. So let's do that. First of all these x's all over the place are really ugly, right? Do I really need to write x to the 4th here and x cubed there? As long as they're in this column, I know what the power of x is. And everything in this column, that's the x squared column. And this is the x column. And this is the constant column. Right? So why don't I just skip that? I'll just write this. I'll divide by plus 2. No need to write the x. I know what belongs there. And there's no need to write the x to the 4th. I'll just write the coefficient, the invisible 1. I'll make it visible. The next coefficient is plus 6, but there's no need to write the x cubed. I know that this is the x 4th term. This is the x cubed term. Here comes the x squared term. I'll just put down the coefficient, plus 5. The next coefficient, minus 4. That's for the x term. And then finally, the constant term, which is plus 2. So, I need to multiply by 1 to get rid of the x to the 4ths, right? So, that 1 goes there, and that'll wipe out that. And then 1 times plus 2 goes in this column, and it gives me a plus 2. I subtract, and I get my plus 4. Just like I did here. So, what has to multiply 2 to get rid of this 4? Sorry, what has to multiply 1, the invisible 1 here, to get rid of that 4? A plus 4. 4 times the invisible 1 gives me the plus 4, but it also hits the 2, so I get that. This disappears. 8 subtracted from 5 gives me negative 3. And of course, you know, we're gonna always arrange it so that we get the same thing down here to subtract, so there's no need to write that either. Only that. Then I need a -3 to multiply with the invisible 1 to give me a -3 here. I'm not going to write that -3 again. -3 hits the +2, gives me a -6. -6 gets subtracted from the -4, and I get a +2. Right? That's this step here. And then I'm going to need 1 to get rid of this 2. Sorry, I'm going to need a -2 to get rid of this 2. Yeah, that's the ticket. And that leaves me with a -4 over here, which I subtract from that. Or I add with that, no, I'm sorry, gives me, I'll get it. It's a +2, right, just like it was there. +2, hits that 2, gives me the +4. I subtract that from 2, I get -2. And that's my remainder. I can't go any further. So I did all the same steps. I didn't do it easily, but I did it without writing the x's. Good. That's progress. Now, let's simplify it a little more. There's a lot of white space here. Can we just scrunch it into a couple of lines? Sure. We'll put our work on less lines. So it's +2 into this, just like I wrote it here. And I end up bringing down the 1. The 1 multiplies the 2 and gives me the 2. I subtract and get the 4. The 4 multiplies the 2, gives me 8. I subtract, get the -3. The -3 multiplies the 2, gives me the -6. I subtract and I get +2. All right, I'm down to here now. 2 times 2 gives me 4. Subtract, I get -2. All right, so it's all the same steps, just scrunched up into 2 lines. Can we improve that? Well, most people would agree that addition is easier than subtraction. So, instead of doing all the subtraction with my +2 out there, let me just do it. Let me just change it to a -2, then I can add. Bring down the 1. 1 times -2, -2. I add. Notice the sign change from what happened here, right? All these signs I circled in green because they're all reversed from what we just did. Add 4, 4, -2 is -8. Add, I get the -3 times the -2 gives me +6. Add 2 times -2, -4. Okay, I did all the same computations. This technique, this method, we can't simplify it any further from there. That's pretty good though. This is called synthetic division, is what this operation is called. As you see, it's a lot better than long division of polynomials. These are exactly the same mathematical steps, but much simpler, much faster. So to review the process, you bring down the first coefficient, multiply, add, multiply, add, multiply, add, multiply, add, done. If your remainder is 0, then -2 is a root of the polynomial, which tells you that x plus 2 is a factor of the polynomial. Pretty good. let's look at example 1. This is on page 468. And it says, if x equals minus 2 is a solution of x cubed plus 8x squared plus 21x plus 18 equals 0, find the remaining solutions. Ooh, so it's already got an additional twist on it that the last problem didn't have. But if this is a solution, that means we can factor out that, right? In other words, we can change our problem to that where this is of degree 2, which means a quadratic, and we know how to solve quadratics. We have multiple methods for that. So, let's go ahead and do the synthetic division. Right, there's my coefficients, 1, 8, 21, 18, there they are. Let me do the synthetic division and just double check that this is in fact a factor. So, bring down the 1, 1 times negative 2 gives me negative 2, add them up, 6, 6 times negative 2, negative 12, add them up, negative 9. Negative 9 times negative 2 equals positive 18. I made a mistake. Yeah, add them up. This is a positive 9. 9 times negative 2 gives me negative 18. And I get my 0. So that proves that x plus 2 is a factor of that polynomial. And it also proves those are the coefficients of my quadratic, right? That's my quotient after I do the division. So it's 1x squared plus 6x plus 9 equals 0. All I have to do is factor this so that I can get the rest of the roots of this equation. So I'll go over to here. I set this quadratic equal to 0. This is an easy one. It turns out it's that binomial squared. It's the square of a binomial. If you didn't recognize that, then we'd have to do our usual process. Take the square root of each side. Technically speaking, it's plus or minus 0, but plus or minus 0 is only one number. There's the other solution to our equation. So you see how you can break it down. So do this one. Do number 6 on page 475. We'll see how you make out with synthetic division.